PolyAPI Use Case, Vendor Management, by Darko Vukovic, CEO, PolyAPI, April 3rd, 2025. Modern enterprises rely on dozens, sometimes hundreds of systems to operate efficiently. These systems are usually supplied by a mix of vendors, each with their own supported out-of-the-box integrations. Larger vendors often expect others to integrate with them, while smaller ones are more eager to build new integrations to close deals. As a customer, you appreciate when a vendor comes with existing integrations that you can activate quickly, but the reality is that some integrations are missing. Others don't meet your specific needs. And for any custom development on your site, mobile app, or operational tools, you or your contractors must still build your own integrations to connect everything with the operational systems behind the scenes. Over time, this creates a tangled web of dependencies. Replacing a vendor, say your service management tool or payments provider, becomes nearly impossible without turning it into a complex project. You may be limited to only those options already supported by all your existing vendors. Otherwise, you're left persuading all of them to support the new system, coordinating timelines, and potentially re-engaging contractors to make the switch on your site, app, or customer operational tools. The result? Innovation paralysis. You're stuck with what you have, or face an expensive, time-consuming, complex project to manage and execute. An alternative is to route all integrations through a middleware layer that you control. This transforms many-to-many vendor connections into a simpler many-to-one structure. While it requires upfront effort and investment, it gives you long-term flexibility. You gain leverage over vendor selection, reduce rework, and retain ownership of your integration strategy. And if needed, switching middleware platforms is surprisingly relatively easy as long as you control the source code and configuration logic. It's tempting to seek an architecturally perfect solution, but the best approach is to be selective. Allow vendors to connect directly where it makes sense and route integrations through your middleware where it's critical to do so, as outlined in the key objectives section. Avoid the trap of dogmatically funneling everything through your middleware. Flexibility and control should guide your decisions, not a rigid all-or-nothing mindset. Key objectives. Each business will have different priorities and demands, but here are the 5 primary drivers for employing a vendor management middleware strategy. Mitigate vendor lock-in and costs. When your systems are directly wired into vendors, swapping out a tool becomes painful. Routing through your own middleware allows you to switch vendors without needing every upstream dependent system to follow suit, giving you stronger negotiation leverage and control over long-term costs as a defensive business strategy. Prepare for potential forced system changes. If you suspect you might be compelled to replace a core system due to external decisions, managing that integration through middleware simplifies the transition. This approach enables you to adapt to the new system seamlessly while maintaining compatibility with your existing stack, ensuring you can accommodate the change with ease. Control access and security. Avoid giving vendors direct access to sensitive operational systems. Middleware lets you expose only the specific data and actions a vendor needs, keeping credentials and critical data flows under your control. Support runtime flexibility. Need to work with multiple vendors at the same time? Middleware allows you to route requests to the right provider dynamically based on logic like location, cost, availability, or performance. Customize integrations. If a vendor provides a standard integration that doesn't fully meet your needs, or if no integration exists, middleware gives you the flexibility to adapt or extend functionality without relying on the vendor's roadmap. If these objectives align with your needs, keep reading to see how PolyAPI can help. PolyAPI streamlines vendor management by providing a cohesive framework that enhances control, security, and efficiency in integrating various vendor systems. Its architecture comprises four key components: the inbound gateway, which manages and authenticates incoming requests, allowing you to tailor interfaces for your applications or align with the invocation formats from the upstream vendor integrations. The microservices, where workflow logic is executed, including data transformation, routing, and credential validation, ensuring precise control over data processing and security. The SDK and function catalog, offering pre-built operations and utilities that simplify the development process, enabling efficient and accurate implementation of vendor integrations. And the outbound gateway, which oversees outgoing communications, enhancing observability by logging interactions and monitoring system health, while securely injecting credentials from PolyAPI's vault to minimize exposure risk. Together, these components provide a robust solution for managing vendor interactions, ensuring seamless, secure, and adaptable integrations that align with your organization's objectives. Here's a high-level diagram illustrating these capabilities. Inbound gateway. The inbound gateway standardizes API calls from your applications or external systems. It acts as the interface your internal teams or vendors build against, either by conforming to an existing standard or by defining a forward-looking API that can support multiple vendor systems over time. While it may be tempting to mirror existing vendor APIs directly, this creates awkward dependencies. Instead, design the API around the needs of your internal consumers and the data actually used upstream. Remove unnecessary request and response elements and focus only on the useful data to ensure long-term usability and maintainability. Microservices, server functions. Microservices are deployed as server functions within a serverless environment, orchestrated by Knative on Kubernetes. These functions contain the core logic for validating, transforming, filtering, and routing data. Each function serves as a bridge between the exposed API and underlying vendor or system APIs. By using the SDK, developers can rely on reusable utilities, API wrappers, and shared variables, keeping the function logic clean and focused on integration behavior. SDK, Developer Toolkit. The SDK simplifies interactions between microservices and external systems by providing a rich set of tools and pre-built functions. It includes a comprehensive library of API calls, utility functions, and secure mechanisms for managing credentials and system variables. Customers can take advantage of PolyAPI's pre-built integrations with popular enterprise systems or define their own private functions tailored to specific business needs. By abstracting complexities such as error handling, authentication, and system traceability, the SDK allows developers to focus on business logic, while PolyAPI ensures reliable connectivity and secure transactions. Outbound gateway. The SDK simplifies interactions between microservices and external systems by providing a rich set of tools and pre-built functions. It includes a comprehensive library of API calls, utility functions, and secure mechanisms for managing credentials and system variables. Customers can take advantage of PolyAPI's pre-built integrations with popular enterprise systems or define their own private functions tailored to specific business needs. By abstracting complexities such as error handling, authentication, and system traceability, the SDK allows developers to focus on business logic, while PolyAPI ensures reliable connectivity and secure transactions. Detailed capabilities of each service. If you are interested in learning about the specific features that enable vendor management, the following section outlines the detailed capabilities of PolyAPI. Gateway, inbound and outbound. The gateway serves as the entry and exit point for vendor system integrations, handling incoming events, authenticating requests, and routing them for processing. It ensures seamless communication between systems by facilitating vendor connections and orchestrating outbound interactions. Webhook listeners receive incoming HTTPS requests from various vendor systems and convert them into internal events that trigger microservices. Responses can be immediate acknowledgments or synchronous replies after the vendor integration is processed. Execute endpoints enable vendor integrations to be manually triggered via the UI or API, allowing for controlled testing. Execution IDs assign a unique execution ID to each vendor request, ensuring traceability throughout the integration pipeline. This allows for detailed monitoring and debugging across vendor systems. Security functions validate requests before they are processed, ensuring only authorized calls to vendor systems are fulfilled, reducing the risk of unintended actions. Variable and secret injection securely pass credentials and dynamic configuration values within API calls, ensuring sensitive information is handled safely. Error handler detects and captures failed API calls from vendors, triggering automated diagnostics, alerts, or incident responses to improve reliability. Metrics track execution times for vendor API calls, providing insights for performance monitoring and optimization and SLA validation. Logging capture logs from API calls to vendor systems to provide full visibility into integration executions, making troubleshooting and auditability seamless. Scalability dynamically scales with Kubernetes to handle high-volume vendor event processing without bottlenecks, ensuring integrations operate efficiently at any load. Microservices, server functions. Microservices handle the execution of vendor integration logic, ensuring that integrations run efficiently, reliably, and at scale. They serve as the connector, which handles all the logic in between the APIs created for your enterprise applications and the APIs of the vendors. Language support. Develop microservices in TypeScript, Python, or Java, with C# support coming soon, leveraging built-in libraries and vendor system integrations. Interface schemas. Define structured request and response formats, ensuring that integration developers have accurate models of the data they are working with. These schemas can be reused across multiple integrations and help developers with type safety and accelerated development. Variables retrieve configurations dynamically, such as data mappings and business rules, allowing integrations to adapt in real time. Can be used in a multi-tenant fashion to support multiple vendor mappings or rules with a single integration. Client functions create reusable code blocks that can be used across multiple vendor integrations, reducing redundancy and ensuring consistency. Can be used in a multi-tenant fashion to allow for different execution blocks based on the vendor or partner involved. AI services coming soon enable intelligent integration by allowing AI-powered decision-making and processing without requiring complex logic at runtime without having to write or maintain the code. Read more about our short-term vision here. IDEs and local testing. Develop using any preferred IDE with full debugging support, allowing for real-time validation and iteration of vendor integration logic. Deployment. Integrate with CI/CD pipelines for streamlined releases, ensuring controlled and scalable deployment of integration code. Catalog and management service. Automatically track and manage deployed vendor integrations, providing visibility and maintainability through a centralized repository. Execution console. Manually trigger vendor integrations from the management UI for testing, troubleshooting, and validating logic before full deployment. Logs. Capture execution details, including error conditions, timestamps, and performance metrics, ensuring reliability and traceability. Scalability. Dynamically scales using Kubernetes and Knative to handle increasing demands without performance degradation. Sleep mode. Optimizes resource usage by putting integrations into sleep mode when idle, while automatically scaling up when triggered. Cloud provider optionality. Maintain consistent development and infra across various cloud providers, avoiding cloud provider lock-in and ensuring flexibility. SDK and AI Assistant. The SDK accelerates vendor integration development by simplifying connections and providing reusable components, API, server, client, variable, and AI functions. Provide reusable, modular components that let developers focus on integration business logic while ensuring consistency in inputs and outputs. This approach reduces redundancy and minimizes risk as changes remain isolated and do not disrupt the entire integration. Type schemas. Models defining arguments and response types for all functions, facilitating smoother integration. Function discovery. Enable integration developers to quickly find and use functions, driving efficiency and reducing duplicate development. Code generation. Accelerate the development of vendor integrations by generating API call, scaffolding, connection logic, and mapping. General development help. Leverage AI-powered assistance to improve development productivity, making it easier to build, test, and deploy vendor system integrations efficiently. How PolyAPI is different from market alternatives. PolyAPI offers a fundamentally different approach to vendor management compared to traditional integration platform as a service or integration tools. Instead of relying on pre-built connectors or rigid low-code workflows, PolyAPI gives you the building blocks to design and operate integrations your way, putting developers and internal teams in control of how systems connect and evolve over time. Function-centric design. At the core of PolyAPI is a function-based architecture. Each vendor integration is broken down into reusable server, API, and utility functions. This modularity makes it easy to substitute systems, tailor integrations, and manage changes over time without rewriting entire workflows or relying on a vendor's roadmap. Developer first and natively extensible. Rather than abstracting integrations behind a low-code interface, PolyAPI empowers your developers to write real code using familiar languages, IDEs, and development pipelines. This ensures compatibility with your enterprise tooling while enabling precision and flexibility when working with vendor APIs, no compromises or black box behaviors. Runtime adaptability for vendor variation. PolyAPI supports multi-tenant, dynamic execution, enabling the same logic to adapt at runtime based on the vendor, region, property, or system context. This is particularly useful when supporting multiple vendors for the same function, like payments or CRMs, without duplicating logic or hard-coding behavior. AI-assisted integration development. PolyAPI's AI assistant helps developers write integration logic faster by suggesting functions, handling schema mappings, and offering generated code examples. As it evolves, it will be able to detect breaking changes in vendor APIs, suggest remediations, and improve long-term maintainability, reducing the effort needed to keep integrations up to date. Integrated catalog and knowledge base. Every integration you build with PolyAPI is documented, versioned, and managed centrally, whether created by observing API behavior, importing open API specs, or writing native code. All artifacts, functions, mappings, logs, and credentials are captured in a single source of truth. This reduces knowledge loss, simplifies onboarding, and makes handoffs between teams seamless. Unified inbound and outbound gateway. PolyAPI's gateway structure ensures consistent treatment of all inbound and outbound vendor traffic. It allows for centralized authentication, logging, rate limiting, and observability, so you can monitor, test, and troubleshoot vendor interactions in one place, no matter which system is involved. Secure credential. Handling with Vault. Vendors require sensitive credentials for authentication. PolyAPI's Vault ensures that these secrets are securely managed and never exposed to runtime code or developers. Credentials are injected securely at runtime, reducing the risk of leaks and simplifying audits. Kubernetes, native and cloud agnostic. PolyAPI is built to run on your infrastructure. Whether you're using AWS, Azure, GCP, or a private cloud, you can deploy PolyAPI natively on Kubernetes. This ensures scalability, high availability, and full control over your integration platform without vendor lock-in. A fully managed PaaS option is also available for teams who prefer hands-off operations. AI services coming soon. We're building support for AI-powered integration functions that can dynamically handle schema transformations and routing logic. This is ideal for enterprises needing to integrate with many vendors or legacy systems with minimal effort, especially in use cases where data volume is low and flexibility is critical. Read more here. PolyAPI's developer-first approach ensures that workflow automation remains scalable, flexible, and maintainable, a stark contrast to the rigid, vendor-locked models of traditional automation platforms. Modernize vendor management with PolyAPI. PolyAPI redefines how enterprises manage vendor integrations by offering a middleware platform that puts you back in control. Instead of adapting your systems to fit each vendor, PolyAPI enables you to build a flexible, secure, and maintainable integration layer tailored to your needs. Its function-centric design, unified gateway architecture, and developer-first toolkit empower your team to manage complexity without compromise. Whether you're substituting systems, enforcing access policies, or supporting multiple vendors in parallel. With built-in observability, secure credential handling, and runtime adaptability, PolyAPI gives you the agility to evolve your vendor ecosystem without costly rewrites or delays. Take charge of your integration strategy and your future. Ready to take automation to the next level? Email us at hello@polyapi.io. Try our platform by signing up on our website or book a time to meet with us in person.